Welcome to Wes Explains Best. Today we're going to be doing a Khan Academy tutorial on area of a segment of a circle. To understand what a segment of a circle is, you really got to understand a couple different concepts. This is a really tricky concept because it includes a lot of information from other sections. So let's try to break it down right now. So the segment is this little circular, kind of looks like a little moon shape, I guess you could say. It's that little section there. So the area of a segment. Well, in order to understand the area of a segment, we have to see that it's the components of a couple different shapes. One, we would have this whole sector here. So that whole sector, that little purple piece of pizza right there, little slice of pizza, that is a sector. So a sector is a part of a circle that connects two radii, radius to the center of the circle. So that's the center of the circle. So that's the sector. Okay. So the area of the segment is equal to the area of the sector, and then notice how we have this third shape here. And you should recognize this shape. This is a triangle. Okay. So let's just put dots in there. So this is the triangle. So then we have this third shape, which is the triangle. Now the sides of the triangle, oops, I need to extend this out a little bit, not to scale. So the sides of the triangle are the radii of the circle. So it's kind of useful that we have a lot of the same measurements being used for all of these, but now we just kind of have to keep them straight. Now what's important to know? Well, how do we get the area of the segment from the area of a sector and the area of the triangle? There's some extension here. So this little portion is included in the sector, but it's not included in the triangle. So how do we get just the triangle? Well, we have a video on how to find kind of the shaded region. You take the area of the sector, that's the big one, and you subtract what you don't want. You don't want all that space where the triangle is. So you subtract the area of the triangle, and that is equal to the formula of the area of a segment. So there's a lot of moving pieces here. We have to keep a lot of information straight and correct. So let's go ahead and try to do that. So now that we have the breakdown completed, we can go ahead and get started. So what's some important information? Well, we need to know, how do we find the area of the sector? The area of a sector, as I explained in a different video, is equal to pi r squared, because that's the area of a circle, times your central angle divided by 360 degrees, okay? This theta divided by 360, this little portion right here, tells you what portion of the circle you're finding the area of. Because the whole circle is this. That's the whole circle. So if you only want a portion of it, then you multiply, I forgot the end here, you multiply it by the angle that you want divided by the entire angle of all the circle 360, and that will tell you the area of the sector. So we do have r already. We already know r. r is 5. So we got that. We already have our central angle. That's 90. So we got that. So we're good to go on area of the sector. So let's go ahead and calculate that. I think that makes sense to go ahead and proceed there. So we're going to do times 5 squared. Make sure to do this squaring the 5 first. The common mistake that I see from my students is pi times 5 and then squaring that result. That is not what you want to do. Times 90 divided by 360. So we can leave your answer, actually it wants your answer in terms of pi, and that's the same thing I would do for my students, is just ask them to leave it in terms of pi. So I'm just going to multiply straight across. I have 25 times 90 divided by 360, and I get the area of my segment is 6.25, and then I have to tag a pi on there. So I have my first part. First part is good to go. Now I need to find the area of the triangle. So there's a couple different strategies we need to utilize here. So when the angle is 90 degrees, that makes it easy for us, because we know that a base and its height are perpendicular to each other. So when it's 90 degrees, it makes it easy. We can just use area equals 1/2 the base times the height. What happens when it's not 90 degrees? Well, now you need to use some trigonometry. And our trigonometry formula for the area of the triangle is 1/2 b times c times sine of a. Because notice how we have a side, an angle, and a side. This is side, angle, side, trigonometry, finding the area of that. Now, the one thing that's going to be different about when we're using finding the area of a triangle within a circle is B and C are both the radius. So technically, we could rewrite this for in the case of when it's a triangle within a circle, it's 1/2 times r, which is r squared, times sine of A. Now, I don't want you to get confused and like try to memorize a new formula. So if you just memorize this, you'll be okay. Just know that your B and C are going to be the same, and then sine of A is going to be your central angle. So let me write that there. These two are going to be your radii, and then this is going to be your central angle. If you want to pause this video at any time to copy down the notes, that might be advisable. So let's go ahead and find this area. I'm going to go ahead and use the BC sine of A. If you want, you can use 1/2 base times height because it's 90 degrees, but I'm going to use 1/2 base times, or BC times sine of A. So 1/2 times 5, that's BC, and then sine of A. So sine 90. Now when I type this into my calculator, sine of 90 is 1, so then really we just get 25 over 2, 12.5. That equals my area. So now I have the area of the sector, I have the area of the triangle, and now I just need to subtract them. So I have area equals 6.25 pi minus 12.5. Now it's asking to leave your answer in terms of pi, so you're going to leave it like that. I know that looks ugly, but that's how your answer needs to stay, because we can't combine these because 12.5 does not have a pi, so we can't combine them. So 6.25 minus 12.5 is going to be our answer. 6.25 pi, excuse me. 6.25 pi minus 12.5, and that's going to be your answer. Okay, so let's do one more, just because these problems are a little bit longer. A circle with radius 9 has a segment with a central angle of 60. What is the area of the segment? Enter your answer in terms of pi and square root of 3. Okay, now normally I would say for the triangle on this one, you should use, because it's not 90 degrees, you should use A equals 1/2. Sorry, that's a 1. BC sine of A. I definitely did not bank on having that little space, so let me erase that. I would say normally use that, and I'm going to write that still. Area equals 1/2 BC sine of A. Okay, but in this case, since it's 60 degrees here, it's an isosceles triangle, so this is 60, this is 60. We can use a different formula that has square root of 3. Because we have to leave it in terms of radical 3, we can use the area of an equilateral triangle for this one. So the area of an equilateral triangle is side squared radical 3 over 4. For those students of mine, just keep in mind, I am going to let you use this formula for all the triangles. Don't worry about how, oh, it's a 90 degree angle, oh, it's a 60 degree angle, I need to change my formula. Always use this for me. Now, for this Khan Academy, it's getting you to apply your thinking a little bit further. So just keep that in mind, okay? So we're going to use that formula for the area of our triangle. Keep in mind also that we need to find the area of this sector right here. So the area of the sector, don't forget, is pi r squared times our central angle divided by 360. So we have our two formulas we're going to use this time. And know that the segment, the area of the segment is going to be equal to the area of the sector minus the area of the unwanted area, the area of the triangle. Okay? Let's go and get started. I guess we'll start with sector again. So pi r squared, pi times our radius. This time the radius is 9. So we have 9 squared times theta, which is 60, divided by 360. So we're going to leave that in terms of pi, so we're going to multiply across and just tag the pi on at the end. 81 times 60 divided by 360. I'm typing this on my calculator. I get 13.5 pi. Okay, so we have the area of the sector already, 13.5 pi. Now we need to find the area of the triangle. So we're going to use our equilateral triangle formula. Our side is the radius, which is 9 squared, radical 3 over 4. So I have 81 divided by 4, and that is 20.25 radical 3 is my area. 20.25 radical 3. And that's going to be the area of my segment. Now, there's nothing I can simplify further here because there's a pi, there's a radical 3, they're not like terms, so we're just going to leave them. So we're going to have 13.5 pi, 13.5 pi minus 20.25 radical 3. 20.25 radical 3. And there you go. So the key to these problems are taking the area of the sector minus the area of the triangle, and then you get your segment because it's essentially one of those shaded region problems. Just know that you can use 1/2 times b times c times sine of a for the area of the triangle, and that works for all the triangles, any triangle that you're going to have within the circle. So I hope this clarifies a few things. In the meantime, be good, be kind, be true, be nice, and be honest, and see you next time.